Hello students, we have already learned the scatter plot. Let us consider the previous examples. This example, the first example, that is the 10 data set, that is 10 samples are given, and two variables, consumption of sugar represented by X and gain in weight represented by Y are given. And we see that the X variable and Y variable has these values 10, 5, and we have formed this chart, this scatter diagram, which is in an increasing manner. Scatter diagram is given by this data set, bivariate data set. And in the second example, that is time in physical activity, and is represented by X, and gain in Y represented by weight represented by Y, given us this data set, this scatter plot, which is in a decreasing manner. Similarly, in the third example, that is time in physical activities and gain in the weight, gave us this scatter plot, which is which is not an increasing manner, which is not in decreasing manner. So it is a constant, just like a constant manner, and we see that the almost this scatter diagram, or almost this scatter plot, is almost parallel to the x-axis. There is no variation is there, and we see that there is no interrelationship between x and y variable. So now we also learned the relation of correlation coefficient with the scatter plot. If it is increasing, if the scatter plot is in increasing manner, we say that it is positively correlated. If the scatter plot is in decreasing manner, we say that this is negatively correlated. And if it is almost parallel to the x-axis, that is all the scatter plots is no variation, there is no interrelationship is in between there, we see that the correlation coefficient is almost zero. So in this scatter diagram, this is not exactly zero, but we can say that there is almost zero. If the correlation coefficient is zero, so then we can say that there is no interrelationship in between these two data sets. That is, if we spend more time in physical activity, I'm just talking about this data set 1 to 10, these samples. Okay, I'm not talking about a large number of population. I'm just talking about this sample. A small 10 samples are taken. Suppose, just only suppose, and we will, if I see the time spent in the physical activities, if it is increasing, then gain in weight, there is no changes, almost no changes, change in gain in weight here happened. That is 10, if we 10 hours 30 gain in weight, 15 hours 32, 25 again 31, then we can say there is no interrelationship in between these two data, though this is almost not possible in the real life situation. We know that is time in the physical activity is increasing, it means there may be the gain in weight, maybe decrease, it should be decreasing. Okay, so this is the original graphical plot, but I've just as an example I'm giving this these three scatter plot, and we are collecting this data, not collecting, I've considered this data. So now we will discuss, that is, what is regression line. So regression line is a concept of curve fitting. That is, it may be a straight line fitting, maybe a polynomial fitting, maybe a logarithmic curve fitting. So regression line is actually a trend. We can also say this a trend line. Trend line, it means that we are now going to draw a straight line. If it is a straight line fitting, then we are going to draw a straight line, and the straight line is just like we see that all these points, the same number of points in one side of the straight line, and the same number of points, that is equal number of points in one side and equal number of points lies on the other side of the straight line. So now I will use this Excel to draw this trend line. Just how can we draw this? Select this data and then click right click and just move here, add trend line. just click on add trend line. Now you will see this is a trend line, or we can also say this is a regression line. Now look at this, there are too many options are there: exponential, linear, logarithmic, polynomial, power, moving average. So the linear is taken here, linear is selected, so that is why if the linear is selected, we will see that this is a straight line, because straight line is a linear curve. That is, we are fitting a straight line, okay, on this scatter plot. So we can see that the minimum variation, what is the straight line which gives us the minimum variation of this in between these points and the straight line. Let's look at these points, these points, all these points, the same number of points, that is 1 2 3 4, and these in the upper side of the straight line, and the same number, almost same number of points, that is 1 2 3 4, okay, almost same number of points in the lower side of the straight line exist here. So we will fit, or we have to find out such a straight line in case of linear regression, so that there will be the minimum variation in between the points and the straight line, or the minimum variation will be there, there is minimum differences will be there. Okay, so this is a straight line fitting, or this is a regression line. Also we can fit a exponential line or a logarithmic line. It means that we can also fit a straight instead of a straight line. If we choose here, look at this exponential, look at this, now the curve, this becomes, this not no more a straight line, this becomes a curve. Okay, and we see that this is a exponential curve. Okay, that is, now we are fitting an exponential curve according to these points, and we see that almost the same number of points here, the upper side, and almost same number of points in the lower side. Some points are on this curve, lying on this curve also, but the things is not that. Things is, we need to fit a curve, we need to fit a exponential curve according to this point, so that we can say that there are the minimum variation or minimum difference exist in between the straight line and the points. Okay, so there are many more options exist here. There is exponential. If it is linear, then we already have seen that this is a straight line, and fitting of straight line is there. We can also select logarithmic. If we select logarithmic, look at this, the curve becomes a logarithmic curve, and we're fitting this logarithmic curve according to these points. That is, we have to find out such a logarithmic function or logarithmic curve which lies in such a manner, so that we can say that a minimum distance or the minimum variation occurs in between the points and the straight line, or points and the logarithmic curve. Similarly, if we select the polynomial, so it becomes a polynomial curve. So we can see that polynomial linear function, it is also a polynomial, and if we select a polynomial, it may be order 2 or order 1 or order 3, whatever, that is x to the power n, but it selects that polynomial function which gives us the minimum variation. So we see that this is a straight line. Why this is a straight line? Because the linear curve in this case gives us the minimum difference, minimum variation. That is why if I select the polynomial, it becomes also a straight line. If I select a linear curve, it is also a straight line. Okay, so if we select a polynomial, there may be, in that case, there is a polynomial, it may be some other degree, or it may be parabola, or maybe a cubic curve also, but it only gives that polynomial function which gives us the minimum variation. In power case also, there is a power curve, that is 1 by x to the power n or something. So now you can also, so now for the sake of simplicity, I choose the linear curve, or the linear regression line here. You can also find out the equation of the curve here. How can you find out the equation of the curve? Just select here in this bar, display equation on the chart. So just click here or select this option, display equation on the chart. So now you will see y equal to 0.8133x minus 3.445. So this is the equation of the straight line. You can also get Now if I select exponential curve, look at this. The equation is equation changes. There is 5.6565 e to the power 0.33x. Okay, so e to the power, so it is since it is an exponential curve, so e raised to the power something. Okay, that is a curve is an exponential. If I select logarithmic, look at this, 27.74 ln x minus something. Okay, so there is a logarithmic curve, so obviously there is a logarithmic function is there. Similarly, in case of polynomial, look at this. There is a square form here, so okay, so this is not a straight line, this is a square curve. Okay, so it's not, we have chosen the power, okay, so we have chosen the power order 2. So we are fitting a two-dimension curve here. Okay, so this is power 2 curve, this is not a straight line. Okay, I have given a wrong statement. That is the linear curve, it has a linear, but this polynomial we have chosen the order 2. Already this order 2 is chosen, that is why it is a second degree curve is fitted according to these points. If I increase the power, that is third degree, look at this, the curve changes. Okay, that is we can select the power of the polynomial here. Okay, if I choose the select that is cubic curve here, so the curve changes as a cubic curve. So if I select to the power 4, that is this is a some fourth degree curve. So it is a fourth degree curve, and this is the regression line of fourth degree curve. Now if I reduce this to 1, so 2 is the minimum, we cannot select, already linear is given here. So in polynomial case, the minimum power starts with 2, so we are fitting here a two-dimension curve, that is, sorry, two second degree curve, that is this is a parabola. Okay, it almost looks like a straight line, that is that's why by mistake I told you this is a straight line, but this is not, it is a parabola. Okay, so similarly we can fit different types of curves along with